Alright, in this video we are going to go ahead and we are going to do some rotations. So let's take a look at this first one here. I want you to notice on this first one it says that we want to rotate this particular pre-image 90 degrees. And notice right now it's in this first quadrant over here. And so I'm going to show you a couple different ways that we can do this. We could do this by using the algebraic rule since it's 90 degrees. But we could also do this simply by using a sheet of paper, of white paper, so that we can trace this particular shape, and then we can rotate this piece of paper and figure out exactly where it's supposed to be once it undergoes a 90-degree rotation. So I'm going to go ahead and just show you how to do it with the paper right quick. And I'm going to take this paper that I just cut out. A couple things that I want to do if I'm going to do a rotation is I want to mark my y-axis and my x-axis. Now I don't have to draw the whole thing out, but I want to mark just little pieces of it. I also mark where origin is because this rotation is going to be, if it doesn't state it, it just says rotate 90, then you're rotating about the origin. The next thing I want to do is I want to go ahead and I'm just going to flip this up so you can see this image right here. And notice when you're looking at this image, right, we have A, B, C. And so I'm going to go ahead and put a point and just label them A, B, and C. Now I'm going to go to connect the dots. So here's my shape, and if you notice, if I lift it up right, it's laid right on top of it. And now what I'm going to do, since it said turn it 90 degrees, I got to think about, well, how much is 90 degrees? And I'm just going to show you with a protractor real quick. When we talk about a 90-degree turn, if I were to put this and line it up, notice this says 90. So in other words, if I went from this point all the way over to this point, that would be a 90 degrees turn. And I'm just going to draw like a little arrow. Right? That would be a 90 degrees worth of turn. In other words, it's a quarter turn. And if I were to turn another 90 from there, right, I'd flip this over on the side. I could go another 90, which is another quarter turn, and another 90, and another 90, and eventually I'd be at 360 degrees all the way back. So just to show you what I mean, I'm going to put a right angle symbol here. This is a 90-degree angle from the y-axis over to the x-axis. If I want to turn it another 90 degrees, I just go from that axis to the next one. And that'll be a 180-degree rotation. If I wanted to go another 90 degrees, I'd say 180 plus 90 gives me 270 degrees. And this would be 270 degrees rotation. And if I wanted to put it back where it originally started from, I would go another 90 degrees, and that would make it 360. And the reason is because there's 360 degrees in every circle. Now, we only want to go 90. I'm just trying to show you an example of the different ones. If I were to move this 90 degrees, it should end up over here in quadrant 1. If I rotated it 180, it's going to be in quadrant, or quadrant 4, I should say. And if I wanted to rotate it 270, it's going to end up here in this quadrant. So notice I'm going to go ahead and get my pen real quick, and I'm going to put it right in the center. And you can, and I recommend doing this with a pencil, but I like to use pen because it stands out better in the videos. And what I'm going to do is I'm going to make that y-axis right there line up with my x-axis. So I'm going to get this, I'm going to hold it in place, and I'm just going to spin it around. And notice now it lines up right here. So I just did a 90-degree rotation. I turned it a quarter turn. What I'm going to do next is I'm going to flip this over. This is kind of the trick to it once you do your rotation. Now you got to keep the paper real still. Don't let it move out of place. And put a point at the B value, the C value, and the A value. And then I'm going to flip it back over, and I'm going to push on it with my pen so that it'll mark those points, their location. And if I flip it back, you can see how that ink has transferred. It'll do the same thing with the pencil. And not only do I have it transferred, but now I can move my image down, and I can see that this top point right here is A prime. Because remember, anytime we transfer a point from its original image, it's what we call the pre-image, then we got to put that prime symbol. That means that it's been transformed. And B is on the bottom, so I'm going to put B prime, and C is over here on the right, so I'm going to put C prime. So you can see that this clearly rotated 90 degrees. The C moved over here, the B moved over here, the A moved over here. And I'm going to go ahead and just connect the dots. Now this is my new image. It's the transformed image that rotated 90 degrees. Notice it did change in what we call orientation. In other words, the C was up at the top, but now it's over on the side. So we had to change in orientation. This shape, it is the same shape. It's a triangle with 1, 2, 3 units on one side, 2 on the other side. This is still 1, 2, 3, 1, 2. But when it rotated, right, it moved around. And so it looks a little bit different. Now, we could have done this with an algebraic rule. I do want to show you what the algebraic rule looks like real quick before going any further, just so you can see to get an idea of how we would have done this with a rule. For instance, the rule a lot of times is going to look like this. And this may look familiar because they showed you these rules back in 8th grade. It's been a while, but you use these rules in 8th grade. And they would have said x and y. And when it starts, you just have what we call x and y. Now, whenever you rotate 90 degrees, and this is just a rule, every time you rotate 90 degrees, I'm going to write a 90 over here, you have to swap the x and y value and change the sign. So I'm going to put right here, I'm going to put swap and change. So let me show you what I mean by swap. The x is going to move to the back. So this becomes x in the back, and it's a positive x, so we're going to change the sign to a negative. In other words, if this value right here was positive, it would change to negative. If this value was negative, it would change to a positive. That's all this symbol right here means. This is change the symbol, right? Because we're putting a negative sign and we're multiplying it to it. We're multiplying -1 to that value. And then the y would come up to the front. So this is for a 90-degree rotation. And if they asked for the algebraic rule, that's what you would put. And I'm just going to show you how this is true. Okay, so think about it. We swapped the x and y value and we changed the x to positive. So I'm going to find the location of 1 point. So it's easier if we just check 1. So I'm going to circle it. We're going to use A. A's location is at 1, 2, 3, 4, 5. So we have -5. And then 1, 2, +2. Now, if this rule is correct, right, which I'm positive it is, then the -5 and the 2 is going to swap positions. In other words, while we did have a -5 here, comma, a 2 here for the point A, I'm going to put A right there. And if I follow this rule, that -5 would have got moved over to the position of Y. So in other words, it would have moved here where this X is, right? And it was a negative, so we would have changed it to a positive. Because this little sign here, right, it means to change the sign on it. So I'm going to write right here, we should have +5. And the 2 would have just moved up to the front. So the y value gets moved up. So put a 2, right, because that's my y value. And this represents a 90-degree rotation. Now let's confirm that. So point A prime should be located at 2, 5. So I'm going to go to origin. I'm going to go over 2, 1, 2, and then up 5. 1, 2, 3, 4, 5. And notice this point right here is at 2, 5. Now, if you think it's easier to figure out the rule and mathematically calculate the change that's going to occur, you can do that. But if you think it's easier to use the piece of paper and just trace it and rotate it, well, you can do it that way too. Now, the neat thing is, this rule about swap and change, every time you go another 90 degrees, you just repeat that rule. In other words, you just swap it and change it again. So I'm going to give you an example over here. I'm going to go over here, and this time I'm going to use the rule first on this one. I'm going to go ahead and write the rules that we have so far. So we started with simply x and y. And then we did what we call a 90-degree rotation. And we ended up with a rule, x and y. And the y came to the front, and the x went to the back and changed its sign. Now in this case, notice they want us to rotate it 180 degrees. So I'm going to use the rule first in this one. So for 180 degrees, we're going to repeat the process. In other words, I'm going to take x and move it back up to the front, and I'm going to take y and move it to the back and change the sign. So that y becomes a -y, and that x, it stays negative and just moves up to the front. Because the only one that we change the sign on is the one that gets moved to the back. So here's our rule for 180 degrees. So I'm going to find 1 point and move it just to prove to you that that this method of swap and change, that it will work every time you move 90 degrees. And A is currently located at 1, 2, 3, and up 1. So negative 3, comma 1. That's our current A value. That's the location of point A. So I'm going to go ahead and say, well, if I were to take that negative 3 and 1, and I'm going to write it up here. So we had negative 3, comma 1. And I were to do some swapping, right? So the first time that we would have swapped it, the negative 3 would have went back and had a sign change. So it would become positive 3. And then we would have moved that positive 3 up to the front. So if this method is correct, which it is, then we should have a positive 3 up in the front for x. And now 1, on the other hand, right, that was our y value. It got moved to the front when we did 90 degrees. But then it got moved to the back and had a sign change when we did another 90 degrees. So that 1 should be a negative 1. And that should be the location of our new point for A prime. So I'm going to go ahead and plot that point real quick, and then I'm going to go ahead and trace this on paper, rotate it, and show you that it did work out correctly. So let me go ahead and find 3, negative 1. I'm going to go over 1, 2, 3, and down 1. So that's 3, negative 1, and that should be my A prime. Now I'm going to go ahead, I'm going to get some more paper real quick. We're going to draw this image and we're going to rotate it. I still think the easiest way to do it is just using this paper and rotating it, but I wanted to show you that there's another way to do it so that you know both. So let me draw that right there. This is my X. That's my Y-axis. I'm going to draw this and put the point at origin. And then now let me trace my shape, right? So there's my triangle. It's A, B, and C. So here's one point, A. There's point B, and there's point C. So A, B, and C. So you can see that clearly right there, A, B, and C. Go ahead and connect my lines. Now we're going to rotate this one 180, which means we're going to do 2 quarter turns, right? Or half a turn. So I'm going to turn it until the Y lines up with that X axis. So it lined up, that's 90 degrees. I'm going to turn it one more time. And until it lines up with the Y-axis but facing upside down, and that is 180 degrees. Now I'm going to move this over just a little bit, and I'm going to flip it over now, and I'm going to do that trick where I'm going to go to those dots that you see right there, right, and I'm just going to put some ink on it. 1, 2, and 3. And this dot right here, that A value is going to touch right there. So I'm just going to press on it to mark it. There we go. Move it over, and notice it hit right there. So even though we use the rule to find it, and no matter if you use the rule or you use the paper, it's going to come out the same. That's my A prime. This point right here is my B prime. This point right here is my C prime. Now again, the orientation of the triangle has changed, right? It looks like it's upside down, if you notice, right? This was right side up. The C was on top. Now C is completely on bottom. And you're going to notice that whenever something turns 180 degrees out, it's basically going to, when it rotates out, it's going to look like it's flipped around the opposite way. So that's how we did it. I showed how to do it with a rule, but I also showed you how to do it simply by using the copier paper. So let's do another one. Alright, so over here for 270, I'm going to start off this time with just using the paper. So let's go to the paper trick again. That's my favorite way to do it, but I will use the rule just to give you a little bit more insight on it. This time I'm going to do it a little bit differently with the rule. I'm going to put numbers in it as we do each step, each 90 degree adjustment, or transformation I should say. And you'll see we'll still come up with the same answer either way. So right now I'm going to flip this over, and I have A, B at top and C and D at the bottom. So this is A, B, C, and D. And I'm just going to connect the lines real quick. So let me connect the lines. Alright, that's my Y-axis, my X-axis. Now it said turn it 270. So 270 would mean that I'm going to turn, a quarter turn is 90, another quarter is going to be 180, and another quarter is going to be 270. So I'm basically going to turn it 3 times. In other words, this y is going to come here, that's going to be 90, come here, that's going to be 180, and then it's going to come here and stop, and that'll be 270. So let me go ahead and do that right quick. So that's going to be 90-degree turn, that's going to be a 180-degree turn, and that's going to be a 270-degree turn. Alright, so I'm going to hold it down, make sure it doesn't move. I am going to flip my paper over. I'm going to put some dots on the points, right, so I can transfer that ink over so I can see where the dots should be, my points. Place this down, press on it, press on it, press on it, press on it, and there we go. I'm going to move it over. And this is now A prime, this is B prime, this is D prime, and this is C prime. And notice that I hold my picture, right? I keep my picture kind of in the same orientation so I can make sure I put the letters in the right place. And let's go ahead and connect these points. So my image, when it rotated 270 degrees, it moved over 90 degrees, 180 degrees, and then 270 degrees. And notice if I rotated it one more time, it'd be back on top of it, right? And it would just look like the original shape. Now, if we were doing this mathematically, let's go ahead and go to what I call our swap and change rule. So swap and change, we're always going to start out with simply x and y and x and y. That's where we started, right? So let's find our points real quick. This time I'm going to do, let's go ahead and do B this time. Let's find B. So there's B. B is at the location of 1, 2, 3. And then, so it's going to be negative 3, 1, 2, 3. And then up 1, 2, 3, 4, 5. And it's going to be positive 5. So we're at 3, 5. So let's go ahead and take these numbers and just substitute them in. We had negative 3 and 5. And I told you this time we're going to do it with numbers instead of doing the letters. Alright, so remember for the first 90-degree rotation, 90 degrees of rotation, we swapped it. We moved the negative 3 back over here and it became positive. And we moved the 5 up in the front. And then for a 180 degrees turn, we're going to swap it and change it again. The 5 is going to move to the back. So it becomes negative 5 because we have a change of sign every time we move one to the back. And then the 3 is going to come up to the front. And then for our 270 degrees turn, which is where we ended up and what our goal was, we're going to swap it again. This 3 is going to come back to the back and change to negative 3. And then negative 5 is going to go to the front. And it maintains the same value, right? It doesn't have a change. Only the one moving back changes the sign. So at 270 degrees, B, I'm going to put point B, should be at negative 5, negative 3. So here I am. I'm going to start from origin. We're going to check it. 1, 2, 3, 4, 5. And then 1, 2, 3. And notice this point is at negative 5, negative 3. So the swap and change method, it works. It works every time. And depending on how many degrees they tell you to go, is depending on how many times you swap those numbers back and forth and change the sign on it as you're swapping them. Right? The one that gets moved to the back has a sign change. Alright, let's look at our final example. We're going to do one that's a little bit different than all the rest of these, right? That was 90, 180, 270. Those are all quarter turns. But what happens when they ask you to do something that's not a quarter turn? Now here's one where it's asking us to turn it 105 degrees, right? But that's not an increment of 90. So that's a little bit more challenging. And so the easiest way I found to do that, once again, is I'm going to use my paper. So I'm going to use my paper over here. I'm going to go ahead, I'm going to mark my axes real quick. So that's my y-axis. That's my x. And I'm going to mark where they cross and origin, right in the center, where the two bolted axes cross. And then I want to go ahead and mark my shape. Now I see I have a parallelogram right here. And so I'm going to put this back down and I'm going to trace it. So that's my A value. And that's my B value. And then I got two more here. I'm just going to look at the letters again, C and D. Okay, so this is C and this is D. Connect my lines. And all I'm doing is tracing it. You may not be able to tell through the camera. I don't know if you can see it bleeding through, but I can clearly see where my shape is when I'm looking at it. Okay, so now what I want to do is I want to turn it 105 degrees. The difference is these are not quarter turns. I know 105 degrees is going to be more than 90. So in other words, when I turn it, I know that I'm going to turn it 90 degrees, and then I'm going to go a little bit past it, right? Because I want 105. But how much is a little bit past it? So what I learned to do is when I have a problem like this, I like to get my protractor and just go ahead and mark the angle. So let me show you what I mean by that. So I'm going to get this, I'm going to line it up. And if I get my protractor and line it up right there, okay, so if I'm starting here, right, this is my 0 mark, and I'm going to go all the way over until I hit 105. And so 105 is going to be roughly, it looks like about right there. That's 105 degrees. So it's 105 degrees of change that occurred, and I just use this, right? The numbers are on top: 10, 20 degrees, 30 degrees, 40 degrees, 50 degrees, all the way until it hit 105. The 105 mark is right in between the 100 and 110. So this is 105 degrees. I just double check it. Yep, that's right there at 105. So now what I'm going to do is I'm going to put my image back on there, and my goal is to spin it around, is to get this y-axis, right? Because it's going to go from y, it's going to go from right here, this y-axis, and I'm going to have it curve all the way around until it hits that point, which is 105 degrees, marked with my protractor. So let me line this up, line all my y-axis, my x-axis, and origin back up. And then I'm going to put my pin on it, and I'm going to turn it until that y-axis lines up with that mark at 105 degrees. And then that would be where my shape is right there. Now these points are going to be real clean points, but this gives you an idea of how you would be able to accomplish this. So I'm going to put a dot right there, a dot right there, a dot right there, a dot right there. And then what I'm going to do is I'm going to go ahead and put my points, connect my lines, and I'm going to write them in, right? So this is my A prime, that's my C prime, my B prime, and my D prime. So now I have rotated this image, right? Notice it changed orientation as it curved around, and I have rotated it exactly 105 degrees. Now I didn't see anything like this in any of y'all's work yet, but most of you, I believe you are going to be headed to this. So I just want to give you an example of what do you do when you have one that's not one of those clean cut 90, 180, 270 degrees rotations. And that's how you do rotations.